And so on. We've selected a few features to show you. Uh, uh, Mainly, it's the expansion of the overall capabilities in terms of data speeds. But beyond that, it's also end user experience, and we're using AI heavily to do that. And the reason we're able to use AI is because we have a built-in NPU inside the modem chip. We've had this for 4 generations, so every year we keep adding more and more features. And because we're always talking about new features, we don't get a chance to show you what the feature did last year. So I have a showcase of a Xiaomi phone that has implemented features that we were showing here last year. So that gives you a glimpse into how these things actually come to market and impact user experience. So if we look at the AI features, we use AI for a lot of things inside the modem. In particular, right now we're using it in what we call the data traffic engine. So we use AI to classify the traffic type that it's seeing, and based on the data pattern, it can tell whether there's a mobile gaming session going on, or a OTT video call, or a voice call, and so on. And based on that classification, it can then determine whether it needs to prioritize or optimize certain apps. For example, if you're gaming, you want your latency to be as low as possible, and it does that on the fly. Because it doesn't have access to the application layer, it doesn't know you're playing a game or what application you're running. But based on the data traffic, it can tell that this traffic looks like a gaming session, and I'm going to prioritize this to get lower latency. So here we're seeing that in action. Similarly, if you're doing a video call on Teams, for example, if you're in a loaded condition, that's what we are measured in the lab here. The regular phone today is kind of on the edge of stalling. Whereas with AI, we're able to determine that there's a OTT call happening, and the modem will allocate more resources to that thread among all the other data threads going through the modem to make sure the most important stuff is getting taken care of. And I think we all have experienced this when you walk into your office or you walk into your home and your phone switches from cellular to Wi-Fi or the other way around. There's always a glitch, especially if you're in the middle of a call. So what we're doing now is, instead of relying on the OS layer like Android to tell you when to switch from cellular to Wi-Fi, the modem can make that decision much better and much quicker than the OS. So as your Wi-Fi signal is ramping down, we can look at the priority apps like a Teams call and move that over to cellular much quicker before the OS even knows it. And that way you don't disconnect your call at all. And this is just one example. You can define priority apps, or OEMs can define it, or operators can, and then we can make this as part of the solution.
Can you also improve Teams?
What's that?
Can you make Teams work better?
This is Teams. I work in Teams every single day. And a broader solution we've introduced that operators really like is being able to, for the modem to be able to force the same IP address whether you're switching a network or not. So what happens is, if your phone is switching from a Wi-Fi to a cellular network, the IP address changes, and that causes a lot of disruption. But with the modem, we're able to force, of course, in collaboration with the operator, we're able to keep the same IP address across sessions. That way there's no discontinuity. So like I was saying, we introduce all these advanced features every year, but do they actually come to market? And we are showing a use case of the Xiaomi 15 Pro of things we talked about last year. 6RX was a new thing that we introduced with the X80. And basically, instead of 4x4 MIMO, this is implementing 4x6 MIMO. So you have 2 extra diversity receive antennas.
Where are the antennas?
In the
corners.
Antennas are rarely in the corners. They're usually on the edges, and you have a lot of edge space. So that's...
You just put more on the edges.
Correct, yeah.
So it's more applicable for like N77 and N79?
Yeah, this particular one was for 70, 78, I believe. But yeah, so Xiaomi shared this data with us from their Beijing tests, and we're happy to show them here. So you can see there's huge difference, and the reason operators like this is because it costs them nothing. It's all on device. Similarly, we have a whole suite of features called Smart Network Selection that's based on AI as well, where we always make sure that the phone is connected to the best cell available as you move through environments, whether it's a train or an elevator or a parking garage and so on. So the Xiaomi device has this, and they are measuring what percentage of traffic has low latency versus a regular phone. So there's a huge gap. So here you can see most of 97% of the traffic went through less than 100 milliseconds of latency across all those scenarios. DSDA or dual SIM dual active is an important feature in China, especially. And they use this ability to aggregate carriers across SIMs. That way, you're improving not only your user experience but also the overall data speeds that you can achieve. So this is like just completely washout, but not all scenarios are like this. But yeah, DSDA capabilities in the chipset give you a lot of options for the operator to implement for different services and delivering better services to consumers.
This started on the X80, right?
X80, correct.
And then 85 has the
85 will have just more, yeah, correct, yeah. And then the last piece, actually before I move on, I know Christian wants me to show this to you. So the reason we're able to deliver those advanced features is because of the end-to-end solution, right? You got the modem, the transceiver, a whole bunch of RF front ends from PAMIDs to filters and switches, antenna tuners, envelope trackers. That way the software is able to optimize as needed on the fly.
Part numbers. What's the same restaurant?
And of course, we keep pushing the boundaries on what's capable at a technical level. So we're supporting up to 400 megahertz sub-6 bandwidth now. Remember, a few years ago, only millimeter wave could do this, right? But now we're there with sub-6. So you can actually cross 10 gigabits per second with just FR1. And then, so all these were done with the infra vendors. I'll show you the examples. We can support up to 3F plus 3T, 1024 QAM. These are downlink features. I can quickly click on these. So here we're doing 4x4 MIMO on 4 channels, aggregating up to 400 megahertz. Gets you to 6.3 gigabits per second.
It's 0.
You want me to start it again? I can start it again.
That's no good. 0. Okay.
All right. Here we have 3T plus 3F, 1024 QAM. And this is 4 carriers on, 4 layers on 6 carriers. Now we moved over to uplink. This is uplink MIMO, 200 megahertz aggregated in N77. Want me to replay that? And this is a switched uplink, which lets the device switch between TDD and FDD, especially when TDD is in the up cycle. You can use the FDD channel for downlink, so your downlink stays high while you're doing uplink. And this was done with ZTE. Beyond this, I have the slide that I showed you guys inside, comparing to the C1 modem. You've already seen it, so I don't. Unless you have questions, I can answer. And we also have some RD measurements comparing the Apple modem to typical Qualcomm modem, mid-tier and premium.
Here's a marketing question, or high-level executive question.
Yeah.
You probably can't comment. Who decides how many bad things you can say about Apple? Because it's still a customer.
Absolutely. It's not bad. It's just comparison. It's motivation.
No, but we're not saying anything bad about Apple. We're just showing you what the device is telling us.
Okay. All right.
Thank you.
All right. Thank you.
Connectivity matters.